So in this video we will study about the strong acid and strong base and how we are going to calculate the pH for strong acids. Since strong acid dissociate 100%, it means thus hydrogen ion of the solution is equal to that of the original acid concentration. So for an example, if we have 0.1 molar HCl and it will give you 0.1 molar hydrogen ion concentration and 0.1 molar chloride ion. So this is 100% dissociation, and we can calculate directly if we know the hydrogen ion concentration. So we can take the negative log of the hydrogen ion concentration to get the pH. So in calculation for the pH for the strong acid, very easy. So let's see one example here, how we can calculate the pH for this nitric acid, where the pH of the solution labeled to 1. Okay, so the HNO3 is concentration is 1.0 times 10 raised power minus 4 molar, and once it will be dissociated, it will give exactly same amount of hydrogen ion concentration and plus NO3 nitrate ion, right? So the concentration, and this will be 100%, so we'll get the same amount of hydrogen ion concentration. And the pH for this acid would be negative log of hydrogen ion concentration, which will be equal to negative log of 1.0 times 10 raised power minus 4, and once we'll calculate the log of this, negative log of this value, will end up pH is 4.0. So pH is 4.0 means it is very strong acid. And now they are asking what is the pOH for this solution. So for the pOH we can use this equation, pH plus pOH is equal to 14, and so pOH will be equal to 14 minus pH, which is equal to 14 minus 4 equal to 10. So this is the way we can calculate the pH for strong acid. And let's talk about the strong base. So strong base comes from the metal and group 1 metal hydroxide and heavy group metal hydroxide. So from group 1 and group 2 metal hydroxides are considered as a strong base, and they also dissociate 100%. So for an example, if we have sodium hydroxide, which is from the group 1, sodium is in group 1, and original concentration of the base solution from the group 1 metal is hydroxide is sodium hydroxide is 0.1. Once it will be dissociate, it will dissociate 100% in the water, and it will give exact same amount of sodium ion and hydroxyl ion. While in case of if we are talking about the group 2 metal, for an example, group 2 metal is here, calcium hydroxide, magnesium hydroxide. So in that case, basically once it will dissociate, it will give you 2 moles of hydroxyl ion. So 1 mole calcium hydroxide will dissociate, it will give 1 mole of calcium ion and 2 moles of hydroxyl ion. And if we have 0.1 mole of calcium hydroxide solution, we'll get 0.1 mole of calcium ion and double of the hydroxyl ion, because for each mole we are getting 2 hydroxyl ion, right? Because of this there are 2 hydroxyl ion as associated. So this is the important thing. And then in group 1, sodium ion plus potassium, and these are all will give you 1:1 ratio. But in case of group 2, for example, calcium, magnesium, barium, so these are all hydroxide. When they dissociate, they will give you double amount of hydroxyl ion. So we'll see few examples to see how we can calculate the pH for basic solution. So pH for the basic solution, we have to find the pH for 0.2 molar sodium hydroxide. So if we have sodium hydroxide, which is 0.25 molar, and after 100% dissociation it will give us sodium plus OH minus. So basically this is group 1 element, and it will give exactly same concentration of hydroxyl ion. Then we can calculate first POH. So POH is negative log of hydroxyl ion concentration, which is a negative log of 0.25, and 0.25 negative log will come around 0.6. So POH for this solution will be 0.OH. You can just double calculate. And then if we have to find out the pH, so pH plus POH is equal to 14, and pH will be equal to 14 minus 0.6, which will be 13.4. So this is the way we can calculate the pH for the basic compound. And let's see one more example. The pH for solution of barium hydroxide. So barium hydroxide is the solution, is coming from the second group element. Once it will dissociate, it will give you barium plus and 2 hydroxyl ion. So if we have 0.25 molar barium hydroxide, it will give you 0.25 molar barium, and double 2 multiplied by 0.25, which will be 0.5 molar double concentration of hydroxyl ion. And now what they are saying, find the pH of this condition. So what we can do, there are two ways we can calculate the pH. So number one is we'll use a simple calculation. Number one, let's do this way: POH first minus log OH ion concentration, that will be minus log 0.5, and this will be 0.3. And once we know the POH, we can calculate the pH by subtracting 14 POH. So that will be 14 minus 0.3, that will be equal to 13.70. This will be pH. And there is one more example, there is one more method we can calculate. If we know that Kw equal to hydrogen ion concentration, and product of hydroxyl ion concentration will be this much. So we can use this method also, that we can calculate the hydrogen ion concentration first at, if it is occurring at 25 degrees Celsius. So this will be Kw divided by OH, and Kw will be 1.0 times 10 to the power minus 14 divided by hydrogen ion concentration we know, which is 0.5. Once we'll solve, this will come 2.0 times 10 to the power minus 14. Now we know the hydrogen ion concentration. and if we know the hydrogen ion concentration, we can calculate the pH. pH is negative log of hydrogen ion concentration, which will be equal to negative log of 2.0 times 10 raised power minus 14. Once we will solve this question, log, we will end up again same 13.7. So there are two ways you can calculate the pH for this type of compound. And there is one more question regarding this strong acid and strong base. So what is the concentration of the solution of KOH that have a pH of 11.09? So very easy. KOH is first group element, it will give K plus OH minus, and 11.89 molar. Sorry, this is the pH. What is the concentration of solution? So pH is given for this solution is 11.89, and now they are asking what is the concentration of hydroxyl ion solution. So basically, if we can find out the hydroxyl ion concentration, we can get the KOH concentration. So let's calculate the hydroxyl ion concentration. So we know that pH and pH we know plus POH will be equal to 14, and POH will be equal to 14 minus 11.89, which will be equal to 2.11. So first we calculated POH. What will be the POH for this solution? Once we know the POH, what we can do, we can take the hydroxyl ion concentration by taking 10 raised power of POH. So this will become 10 raised power minus 2.11, and for this you need to calculate using calculator. Once you will calculate, it will come around 7.8 times 10 raised power minus 3 molar. So this is the way, these are the three examples regarding the strong acid and strong base, pH and POH calculation, and hydrogen ion concentration and hydroxyl ion concentration. And in the next video we will start for weak acid and weak bases.